Hello and welcome back, Geometry. This is our last lesson in Chapter 7, Polygons. We are going to be talking about kites and trapezoids. This set of notes is broken into 2 different days. So we're going to get started with day 1. There is a do now at the top. Take a second to pause and select all figures for which the given property applies. All figures, all right? So pause, check it out. All right, diagonals bisect opposite angles. That is a rhombus and a square. Quadrilateral is equilateral and has 4 right angles. Equilateral, all the sides are congruent. That's a rhombus and a square. But also having 4 right angles, that's only a square. Only a square has both those properties. And then diagonals are congruent. Diagonals are congruent for rectangles and for squares, of course. So let's take a look at another special set of quadrilaterals, which is called trapezoids. All right, all trapezoids have these properties. They have one pair of opposite parallel sides. So one pair of opposite sides is parallel, not both, just one. And adjacent angles between the parallel lines are supplementary. And this makes sense. If we think back to our chapter 3 when we were learning about parallel lines, if we have 2 parallel lines here, this line is a transversal then. And if we think about that, that means angles 1 and 4 are consecutive interior angles. Consecutive interior angle theorem says that they are supplementary. So it makes sense. Let's talk about a special kind of trapezoid though, and that is an isosceles trapezoid. These have 2 sides that are congruent, but not parallel. So let's take a look at that. The non-parallel side legs are congruent. The base angles are congruent. All right, so in our figure up here, this is what we call base 1. And then this guy down here would be base 2. So our base angles would be 3 and 4 here. Technically 1 and 2 would also be base angles, but we usually think about 3 and 4 as our base angles. So we know base angles are congruent for isosceles trapezoids. And I'm just going to sketch out an isosceles trapezoid right here. So this is parallel, and then these legs are congruent. The bases are not congruent, the legs are congruent. The next set of properties is that the diagonals are congruent. All right, the diagonals are congruent. So that would be AC and BD. AC is congruent to BD. And then the last one is that opposite angles are supplementary. Opposite angles are supplementary. So that means angle D plus angle B would be 180, which makes sense because if angle D and angle C are congruent, because base angles are congruent, then angle B plus angle C would be 180. And since angle D and angle C are congruent to each other, I can just substitute D for C, so I have angle B and angle D are 180. So let's use some of our properties and solve some trapezoids. For number 1 down here, as I slide my page, we have angle J is 87, and we have angle L is 51. Our X should be right here. I didn't, for some reason, get it printed, but it should be right there. So this is not an isosceles trapezoid, which means we can only use the properties of trapezoids. And the properties of trapezoids is that angle J plus angle M, so these 2 right here, are consecutive interior angles, so they are supplementary. So that means I have 87 plus angle M equals 180. So when I subtract 87 from both sides, we have that angle M, which is our X, is 93 degrees. All right, for number 2 here, we have 2 angles. They are Again, supplementary. So we have 54 plus 8x plus 6 equals 180. So we have 8x plus 60 equals 180. That would be 8x is equal to 120. So x is really 15. All right, let's turn the page over. So we'll check out page 2 of our day windows. I want you to try number 3, and we are finding x right here. Number 4, because we are finding x right here. And then for number 5, oh, let's do a y here as well, and a y here as well. And then for number 5, let's say we know df is equal to 3x plus 12, and ge is equal to 5x minus 16. All right, take a minute, pause the video, try solving 3 and 4. Try solving 3 and 4. All right, for number 3, you should have 62 plus x is equal to 180. That means x is equal to 118. For y, you should have 31 plus y is equal to 180. So y is equal to 149 degrees. For number 4, you should have 112 is equal to x, or equal to angle r. Because this is an isosceles trapezoid, that means that our angle P and angle R are congruent, so x is 112. And then we have 112 plus y is equal to 180, so y must be 68 degrees. All right, let's do number 5 and number 6 together. So for number 5 and number 6, we know that the diagonals are going to be congruent. So we have 3x plus 12, it doesn't look like a 12, but I promise it is equal to 5x minus 16. So we get 28 is equal to 2x, which means x is equal to 14. For number 6 here, and I think these were supposed to be isosceles and it didn't get labeled, but that's okay. For number 6 here, we have 14x minus 25 plus 3x plus 1 is equal to 180. So angle V plus angle T is equal to 180 would be our setup. So we have 17x minus 24 is equal to 180. So 17x is equal to 204. That means x is really 12. All right, let's slide the paper up and take a look at the mid-segment theorem. The mid-segment of a trapezoid connects the midpoints of its legs. So E is the midpoint of AD, F is the midpoint of BC. So interesting part of this theory, it has 2 parts. The theorem. The first is that AB, we know, is parallel to DC, and it's also parallel to EF as well. So all 3 of these are parallel. It kind of reminds us of that chapter 8 triangle mid-segment theorem, right? Very similar. The other thing is that EF, right here, is equal to 1/2 of AB plus DC. Another way of saying that is that EF is basically the average of AB and DC. All right, it's the average of those 2. So base 1 plus base 2 divided in half is equal to the mid-segment there. So let's try this out. For our first one here, we know AB is 14 and DC is 26. We want to find EF. So EF is equal to 1/2 AB plus DC. So EF is equal to 1/2 of 14 plus 26. Well, 1/2 of 40 in that case would be 20. So EF is 20. Not too bad. All right, I want you to pause the video, try 8, 9, and 10. Pause the video, try 8, 9, and 10. All right, for 8, you should have gotten EF is equal to 19. For number 9, you should have gotten AB is equal to 6, because you have 22 is equal to 1/2 AB plus 38. So I'm going to multiply 2 on both sides. So we get 44 is equal to AB plus 38. Subtract 38, so we have 6 is equal to AB. And then for our last one here, you should have gotten DC is equal to 53. It's the same sort of process as with this one. All right, moving to the top of the third page, all right, this guy right here. There we go. It's numbers 10 and 11. So for this one, we have YZ is equal to 1/2 PQ plus SR. So we're going to plug in what we know, which is 5x minus 19 is equal to 1/2 PQ is 38 plus x plus 14. We have 5x minus 19 is equal to 1/2 x plus 52. I'd rather not have a fraction in my problem, so I'm going to multiply both sides by 2. And I have to multiply everything by 2. So this gets me 10x minus 38 is equal to x plus 52. So I'm going to subtract x on both sides, add 38 on both sides. I get 9x is equal to 90. Well, that means x is 10. Let's take a look at this one right here. Oh, if x is 10, then what's yz, right? Yz is 5 times 10 minus 19. So then yz must equal, that'd be 50 minus 19. So that should be 31. All right, for UV here, because it's our next problem, for UV, you should get an x equals 2 when you solve it. And then when you plug it back in, you're finding UV. So that would be 8 times 2 minus 3. So we get 16 minus 3. So UV has a length of 13. The notes that are posted online have all of these problems solved and fully worked out for you to look at. All right. This is where you should stop the video for day 2. All right, for day 2, here is our do now practice. We have LM as the mid-segment, solve for x. So when you solve this, you should get x equals 5. All right, you should get x equals 5. Yesterday we talked about trapezoids. Today we're going to talk about kites. So this is the day 2 of lesson 7.5. A kite is a quadrilateral with the following properties. It has 2 pairs of consecutive congruent sides. All right, so this guy and this guy are congruent, and then this guy and this guy are congruent. Consecutive, not opposite, consecutive. It also has 1 pair of opposite angles that are congruent. So this angle is congruent to this angle. And that makes sense. If I use my pencil here to divide this into two triangles, we could see that we have a side angle side and a side angle side. So we could actually draw in this diagonal right here, and that would be side, side, side. So we could prove using some of our triangle theorems that these angles are congruent. The diagonals are perpendicular. The diagonals are perpendicular. So there is a right angle here with our diagonals. So that's the properties of a kite. Besides going out and flying one, these are the properties of a kite. So let's do some geometry with it. For problem number 1 down here, we are looking to find the measure of angle B and the measure of angle D. So we know that we have an 85 and a 43. We also know that this angle is going to be congruent to this angle. Pick some variable that you like. It doesn't matter what you want. I'm just going to stick with X because that's what we typically use. We also know the interior angle sum of this. This guy is a quadrilateral, so it's going to equal 360 for our interior angle sum. So that means that angle A plus angle B plus angle C plus angle D equals 360. Well, we know that angle A is 85. Angle B we called X. Angle C is 43. And angle D is also X. So now I'm just solving this, right? So we have 360 is equal to 128 plus 2x. So we have 232 is equal to 2x. That means x is equal to 116. So each of these angles is 116. All right, for our next one, we know that angle J and angle L are congruent. They're the opposite angles that are congruent. And I know that because I can see, and this is really bad to me, I know, but these ones should have been marked as congruent. And that didn't show up in your guys' picture. My bad. Just goes to show you I'm human. So we know that we have 360 equals angle J plus angle K plus angle L plus angle M. So that's 360. I'm going to call this guy X. J and L are congruent, so this is 82 plus X plus 82 plus 71. So when I do that, I should get X plus 235 is equal to 360. That means X is 125. So angle K is 125, and then angle J is 82. All right, let's take a look at the very, very last page. I'm going to flip mine over. Very last page. So for our first problem here, for number 3, we have a measure of angle 1 is what we're looking for first. Well, we know with kites that the diagonals intersect at a perpendicular. So angle 1 I know is 90. No matter what, I know it's 90. Also, looking at this, I can assume, because I'm told it's a kite, that these two are the ones that are congruent and these two are the ones that are congruent. So you can mark those right off the bat. Because I am told it's a kite, I can do that. We're looking for the measure of angle 2 next. The measure of angle 2 next. Well, I know that this angle right here is 37. So angle 1 plus 37 plus angle 2 is going to equal 180. Because this shape right here is a triangle, I know they all three add to 180. Angle 1 we know is 90 because it's diagonal. So I get 127 plus angle 2 is equal to 180. That means that angle 2 must be 53 degrees. Angle 2 must be 53 degrees. So now I am looking for angle 3. There's a couple different ways to find angle 3 here. My favorite way is to ignore this bottom half of the kite and to just look up here. And I can see that I have two congruent sides of a triangle. Well, that would be an isosceles triangle. The isosceles triangle base angle theorem says that this angle and this angle are congruent. So that means I automatically know by the base angle theorem that angle 3 and 37 degrees are congruent. Another way you could do it is if you know 37, you just found angle 2. It said that the diagonals bisect the angles, right? So angle 2 would be the same here, so you could double it. And then you could add that to angle 3, so you could add those angles all together. There's lots of different ways, but like I said, I just like using the base angle theorem. It gets me there very directly. All right, for number 4, we have WX is equal to 14. I'm going to label that on here. And we have that WR is equal to 8. I want to find RZ. I want to find RZ. So I know that this is a right angle right here. That means that this triangle is a right triangle, and I can use a squared plus b squared equals c squared. Hey, it's like it never goes away. Isn't that great? My 14 is going to be c, so I've got 14 squared here. And then 8 squared plus, I'm just going to leave it as a b squared for this guy right here. When I do that, I get 64 plus b squared is equal to 196. That means b squared is equal to 132. So b is equal to 2 square root 33. Now I know that this is congruent to this because it's a kite, right? So 14 and 14. I also know that WR is congruent to itself. So I now have two sides and it's a right angle. We would call that hypotenuse leg. So by hypotenuse leg theorem, triangle WXR and triangle WZR are congruent to each other. That means that whatever I found here for XR is going to be congruent for RZ. So RZ is equal to 2 root 33. All right, I want you guys to try number 5 and 6. Try number 5 and 6. Pause the video, try those two. All right, for number 5, you should have gotten that angle RQP plus angle QRP plus angle QPR is equal to 180. We know that this angle right here is 90 degrees, and we know that this angle and this angle, by base angle theorem, are going to be congruent, right? So we can plug in 4x minus 7 plus 90 plus 11x minus 23 is equal to 180. When we do that, we have 15x plus 60, it's a weird looking 6, sorry, equals 180. So 15x equals 120. That means x is 8. For number 6 here, we have DE is 15 and EH is 11. And I have a right angle here, so I can use a squared plus b squared equals c squared. 11 squared plus, let's call it x this time, x squared equals 15 squared. So that should be 121 plus x squared equals 225. So x squared is equal to 104, which means x is 2 root 26. Now, we are looking for DF. DF is this whole thing. Now, I already said that DH is x, and we've proven using hypotenuse leg theorem that HF is also x. So that means DF is going to be equal to 2x. X we said was 2 root 26. That means DF is 4 root 26. All right, let's take a look at numbers 7, 8, and 9. For number 7, we are solving for x. Again, this is a kite, so I'm telling you it's a kite. You can automatically mark that the consecutive sides are congruent. That means angle A is congruent to angle C. So I can say 8x minus 27 equals 3x plus 58. When I solve this, you should get x equals 17, right? Because we get 5x equals 85. So x equals 17. For number 8, we have the measure of angle BCD. So BCD, that's this whole thing is what we're looking for. All right, that whole thing. Now, we know that it's a kite. I'm telling you it's a kite. And we can prove that this triangle is congruent to this triangle. That means the angle BCE is congruent to angle DCE. That diagonal bisects angle BCD is another way of saying that. So that means that we can have 9x minus 1 is equal to 2x plus 13. And again, that's using the hypotenuse leg theorem. Hypotenuse leg theorem. Who knew those triangles were going to be so handy, right? So you should have 7x equals 14. That means x is 2. Now we're actually looking for that angle. I'm just going to pick an angle, BCE, for example. That'd be 9 times 2 minus 1. So we get 18 minus 1, that's 17. So if we have 17 plus 17, we get angle BCD. So that should be 34 equals angle BCD. All right, number 9, our very last example. We are looking to find angles 1 through 7. All right, angle 1 through angle 7. We can mark these as congruent and mark these as congruent. Let's just start with the easiest one, in my opinion, which is angle 4. It's where the diagonals intersect, therefore it is a 90-degree angle. 90-degree angle. The next easiest one, I think, personally, is going to be finding angle 6. Because we have a triangle right here, and we know that 43 plus angle 4 plus angle 6 is equal to 180. And we just found angle 4 is 90. So 43 plus 90 plus angle 6 is equal to 180. So you should get that angle 6 is 47 degrees. Angle 6 is 47 degrees. We can prove that this triangle right here and this triangle are congruent by the hypotenuse leg theorem. Therefore, angle 7 is 43 degrees. Angle 7 is 43 degrees because angle 7 and 43 align, right? They match up. We can also prove that angle 3 and angle 6 are congruent. So angle 3 we know is 47 degrees. So the ones that we are left with are angles 1, 2, and angle 5. 1, 2, and angle 5. Let's take a look at angle 1 next. Angle 1, again, we know that this is a right angle right here. So we have angle 1 plus 18 degrees for this little corner guy plus 90 equals 180. That means angle 1 must be 72 degrees. Now that I know that angle 1 is 72, I can compare these two upper triangles, and using hypotenuse leg theorem again, I can say that they're congruent. So that means that 18 degrees aligns with angle 5, and that angle 1, my 72 degrees, aligns with angle 2. And that's how we find out all of the angles. Please email me if you have questions. I am here to help you. All right, I'm here to help you. But these are the last lessons. So, skills practice is posted to Big Ideas.